Welcome students, we are given this question. Given that x comma y element of real numbers and that x squared positive y squared is equal to 7 and x cubed positive y cubed is equal to 10, we are expected to find the value of x positive y. Now there are many ways to arrive at the solution of this question, but in whichever way that we are proceeding towards, it is imperative that we take note of this particular requirement for this particular question, that is x and y should be element of real numbers. Now, having understood the question, what I would do is I would first start off by considering this particular formula. We know that x positive y raised to the power 3 is x cubed positive y cubed positive 3 times x squared y positive 3x y squared. This is a formula we've been used to. Now what I'm going to do is I'm going to write this formula as x cubed positive y cubed as one package, followed by 3 times of x squared y positive 3 times, in fact 3 I have taken out, so this is going to be x times y squared. So this is the second package. Now on the left hand side I've got x positive y raised to the power 3. Now in the question we've been given that x cubed positive y cubed is 10. So let me substitute that. So 10 positive 3 times of x squared y positive x times y squared. On the left I've got x positive y raised to the power 3. Now what I'm going to do is I'm going to name this system as equation 1, and then I'm going to head on to consider x squared positive y squared is equal to 7. Now I will be multiplying both sides by x positive y. Now when I do that, this is going to be x positive y times x squared positive y squared is equal to x positive y times 7. Now let me remove the parenthesis for the left hand side. So that is going to be x into x squared x cubed, x into y, that's going to be x times y squared, in fact x into y squared. It's going to be y cubed is equal to 7 times of x positive y. Now I can rewrite this as x cubed positive y cubed followed by positive x times y squared positive y times x squared. So this is one term which is equal to 7 times of x positive y. Now what we can do is we can use the value for x cubed positive y cubed, which is given as 10. So let me write that down, followed by I'm going to retain this x times y squared positive y times x squared is equal to 7 times of x positive y. Now I can move this 10 to the right hand side. That would give me x y squared positive y x squared is equal to 7 times of x positive y negative 10. Now what I'm going to do is I'm going to take this value for xy squared positive y x squared and substitute it in 1. So if I were to do that, therefore 1 can now be rewritten as x positive y raised to the power 3 is equal to 10 times positive, in fact 10 positive 3 times of, in place of xy squared positive y x squared, I'm going to substitute 7 times of x positive y negative 10. Now by the distributive property I'm going to remove the parenthesis, so that is going to give me 10 positive 7 times 3 is 21 of x positive y negative 3 times 10, that's going to be 30. Now 10 added with negative 30 would give me negative 20, so let me write it down. So first 21 times of x positive y, and that is followed by negative 20. On the left hand side I've got x positive y raised to the power 3. Now what I'm going to do is I'm going to use this space here for x positive y. In fact let me first write this down in this fashion: x positive y raised to the power 3 negative 21 times of x positive y positive 20 is equal to 0. Now I'm going to take x positive y to be equal to some t. So let me do that. Let me use the space here. Let x positive y be equal to some t. So if I were to take this as 2, therefore 2 can be rewritten as t raised to the power 3 negative 21 raised to the power 21 times t positive 20 is equal to 0. Now this is similar to ax cubed positive bx squared positive cx positive d is equal to 0. Now if a positive b positive c positive d is equal to 0, then x is equal to 1 is a root. So based on this fact, I want to take in the coefficients of t cubed and t and the constant. So that would mean first the coefficient of t cubed, that's going to be 1, the coefficient of t squared, that's going to be 0, the coefficient of t, that's going to be negative 21, the coefficient of the constant, in fact the constant term is going to be positive 20. Now 1 added with negative 21 would give me negative 20, 0 added with 20 would give me positive 20, negative 20 added with positive 20 would give me 0. So we are looking at x is equal to 1 as a root because of the condition being satisfied, but in this case we are not dealing with x, we are dealing with t. So this would mean that t is equal to 1 is a root. So by synthetic division, I'm going to use synthetic division to show you what happens. I'm going to write the coefficient of t cubed, that's 1, coefficient of t squared, that's 0, coefficient of t, that's negative 21, the constant term is 20. Now t is equal to 1 is a root, so let me place that. Now I'm going to bring this 1 down, so that's going to be 1 times 1 and added with 0, 1 times 1, that's negative 20. 1 time with negative 20 would give me negative 20, so I got a 0 there. So the quotient in this case is going to be, we started with degree 3, so we will have to start now with degree 2. So t squared positive t negative 20. So this is the quotient that we have got. Now we want to find the other roots. So to find the other roots, we will have to use quadratic. So using quadratic, we will find the other roots. In fact, quadratic formula, right? We will find the other roots. So let us do that. So this is going to be t is equal to negative 1 plus or minus square root of, this is negative 1 raised to the power 2, negative 4 times of negative 20 divided by 2. So this is going to be negative 1 plus or minus root of, this is 1 squared, negative 1 squared is 1, negative times negative is positive, 4 times 2 is 80, so we got a quantity like this. So negative 1, 1 added with 80 would give me 81, square root of 81 is going to be plus or minus 9. So I start with a positive 9 divided by 2, this is going to be 8 divided by 2, which is going to be equal to 4. And the other one is going to be negative 1, negative 9 divided by 2, which is going to be negative 10 divided by 2, which is equal to negative 5. So I've got the following. The roots are as follows. So t is equal to 1 is a root, and then t is equal to negative 5 is also a root, then t is equal to 4 is also a root. Now what is the substitution did we start with? We started with the substitution that, let me show you the substitution. This is the substitution that we started with. X positive y is equal to t. So over here the meaning of this would be x positive y is equal to 1, x positive y is equal to negative 5, and then x positive y is equal to 4. Now from here we can clearly see that y is equal to 1 negative x, this is one substitution, and from here y is equal to 5 negative x, that's another substitution, and then y is equal to 4 negative x, that is another substitution. Why are we doing all these things? We are looking for that x comma y which is element of real numbers. So that is the important point, because from here we could have clearly boiled down the values of x and y, but we can't do that, but we need to have this check. Now how are we going to check? We know that x squared positive y squared, this is given, okay, x squared positive y squared is equal to 7. So therefore I'm going to be substituting the value for y. So this is x squared positive, y is 1 negative x raised to the power 2 is equal to 7. If I were to square this, this is going to give me x squared positive 1 positive x squared negative 2 times x is equal to 7. I can rewrite this as x squared and x squared added together, and 7 when it comes to this side will become negative 7, so that's going to be negative 6. I've got a 2x there, so it's going to be negative 2x followed by the term constant negative 6. Now I can divide by 2. This will give me x squared negative x and negative 3 is equal to 0. Now if I were to take the quadratic formula to solve this and find the value of x, I would get positive 1 plus or minus root of negative 1 squared negative 4 times a times c divided by 2 times a, which is equal to 1 plus or minus root of 1. In fact, I don't need to do all those things, but because in this case I'm clearly aware that I'm going to get the value of x, because for the fact all those things is possible because discriminant is greater than or equal to 0. That's the reason I'm doing it. Now, why am I need to be concerned about the discriminant? For the fact that I am interested in finding the value of x and y to be element of real numbers. So just a quick check of the discriminant. If I were to take b squared negative 4ac, from here my b is going to be negative 1. So negative 1 squared, negative 4 times my a is 1 and my c is negative 3. So clearly you can see that this is 1, negative, negative, positive, 4 times 3 is 12. So 12 positive 1 is 13. 13 is clearly greater than 0. And that is the very reason that I am trying to find the value of x. So having mentioned this, we would proceed on to get the value for x. Of course, this is going to be 1 positive. 4 times 3 is 12 divided by 2. So this is going to be 1 plus or minus root of 13 divided by 2. So this is going to be the value of x. However, I need not have to do this. I could have very well concluded that the value of x positive y is equal to 1. But just in case if we are looking into the value of y and x, then it is imperative that we obtain the value of x. So since I have got till here, let me also find the value of y. When x is equal to 1 plus root of 13 over 2, I want to extract the value of y. Since we know that y is 1 negative x, so y is nothing but 1 negative of x. That's going to be 1 plus root of 13 divided by 2. So this is going to be 1 negative 1. I can rewrite this as 1 negative 1 over 2 and then negative root of 13 over 2. So this is going to give me 1 over 2 negative root 13 over 2, which can be written as 1 negative root of 13 over 2. So this is my value for y when x is equal to 1 positive root of 13 over 2. So if we were to substitute the value of x, so let me substitute the value of x. X is 1 positive root of 13 over 2 and the value of y is 1 negative root of 13 over 2. Now clearly this is going to be equal to 1 positive 1. Since the LCM is going to be the same, this is going to be 1 positive root of 13 followed by a positive 1 and a negative root of 13. Both the things gets cancelled, giving me 2 over 2 is equal to 1. So clearly x positive y is equal to 1 and the values of x and y are satisfying. Now we don't have to do all these things. All that is required is to check the discriminant value, and clearly I have shown you that the discriminant is greater than or equal to 0, meaning that x and y are real quantities, and that this is the only point, this is the only value that is going to be satisfying. In fact, this will be the only value. Of course, you can very well take the value of x to be as 1 negative root of 13 over 2. In that case, you will get a reversal of this values that we have just seen. So having mentioned this, this would be the ideal solution, and if you want, you can try out these things. Say for example, you can try out these values when y is equal to 5 negative x, just in case, just for the sake of consistency. If I were to substitute the value of y being equal to 5 negative x, it's not going to work. I can show you that. So x squared positive 5 negative x raised to the power 2 is equal to 7. This is actually raised to the power 2 over here. So this is going to be x squared positive 25 negative 10x positive x squared is equal to 7. I can add these two terms. It's going to be 2 times x squared negative 10x positive 25 and negative 7 is equal to 0. So if you have to add this is going to give me positive 18. So this is 2x squared negative 10x, and followed by positive 18 is equal to 0. I divide both sides. In fact, I divide throughout by 2. This will give me x squared negative 5x positive 9 is equal to 0. If I were to find the discriminant, so in any of these cases we would be able to obtain an x and a y. That wouldn't be an issue at all. But the underlining point is that x and y should be element of real numbers. So if I were to check for the discriminant, b squared negative 4 times ac, they should be greater than or equal to 0. Now let's check for the discriminant. This is negative 5 squared negative 4 times a is 1 and c is 9. This is 25. 9 times 4 is 36. But clearly this is going to be less than 0. So this particular value for x and y will be a total failure. So I think this is the right place to stop, and clearly we have found out the value of x and y, and not only that, we have ensured that x and y are element of real numbers. Thank you, students.